Welcome to the full version of our interview with Professor Jørgen Olesen about the role of scientific innovation in supporting agroecology.
So the main question would be how scientific and technological innovations can contribute to more sustainable food production according to agroecological practices, or better to say, how can they support agroecology?
If we look at agroecology as sort of the way of enhancing synergies between parts of the ecosystems, what we really want to do is to ensure that those synergies we have between plants and soil microorganisms, animals, and so on, work for the better of everything, both in terms of sustaining resources and in terms of productivity, lowering environmental impacts, and so on. Technologies have a very big role in this, and we should also remember that agriculture, agronomy, also agroecology is basically based on technologies that have been developed over time. Much of this, of course, related to breeding, but also managing nutrients and so on. So agroecology is not free of technologies, but we can improve this. and we need to think about how we improve this. Much of this has to do with, of course, looking at some of the individual components by which we influence things. Fertilization, for instance, because we will not have agricultural systems without some sort of fertilization. But the fertilization should be done, of course, in such a way that it doesn't have negative environmental impacts. And there we need to work on the type of fertilizers, whether we have additives or so, how we apply it, the timing, and so on, interactions with soil and so on. So it's both in that case about the type of fertilizer, how we apply it, time it, and so on. Sensor systems in terms of monitoring both the crop, the soil, the conditions, and so on, even forward-looking with weather forecasts and so on, that could work towards optimizing the rates and timing and so on, plays a big role in this. Sometimes we call this precision agriculture. And precision agriculture is also, in my view, part of what we also do with agroecological systems. But agroecological systems is also about having more functional interactions between components of the agroecological systems. And for that, we actually need to work more, in my view, on addressing whether we have the right interactions. So having, for instance, species mixtures in terms of the suitability of interactions between species. This could be both the crops, and you can think about having intercropping systems there. You can have strip intercropping as well, where you can have other types of interactions. You have rotations, you have cover cropping system. So all of those interactions we have there between the plants individually, but also with the soil. In fact, and this is where some of the issues come, the plant breeding that we have been doing over decades have looked at monocultures. So we need to look into plant breeding that takes better account of managing those interactions.
Exactly.
And another point, let me just stress this, because the plant breeding here, the way we are doing breeding and the way we're trying to optimize things, because plant breeding for cereals, for instance, is done under particular circumstances. And the way, for instance, we fertilize crops there is with mineral fertilizers, typically nitrate-rich fertilizers. Now, that of course means that we have developed plants that have a preference for nitrate.
Yes.
However, if we're going to work on some of these interaction systems, we would likely to minimize the availability of nitrate in soils, because nitrate in soils is a source, for instance, of nitrous oxide emissions, of nitrate leaching, and so forth. So we need to have more ammonia-based also plant uptake. That's not how we breed crops. So we need to rethink also our innovation systems, including the plant breeding.
Exactly.
Yeah. But if we have those more complex systems there, it's not just a question of breeding, it's also a question of how we manage them. And many of those systems need to be managed, in my view, much more closely, in particular if we want to avoid the sort of broad scale application of pesticides, fertilizers, and so on, which requires more sensing systems, more sort of closed management, maybe robots, but
exactly. So there,
other technologies, yeah.
I actually have two questions, because I know, for example, in the Department of Agroecology, in our department, Aarhus University, we make use of a lot of drones and satellite imaging. And I actually would like to hear from you how you think they are contributing to the sustainable food production, and what is their role? How do we employ them in agroecological aspects?
Well, honestly, we don't know yet. What the best way of doing this. I think we're still in the start phase of seeing how we can make the best use of sensing systems, such as we have with drones or satellites or whatever. And the reason why I'm saying this is because the way we are trying to apply these systems is in our current agricultural systems. I think we need to rethink things. We need to rethink the way cropping systems are designed. Not just think that we have the current cropping systems and then we put technologies on top of that. No, because that will not lead us to where we need to be in terms of minimizing environmental impacts, leaching and so on, and minimizing climates and so on. We need completely changed systems, right? So, and this is where we need to rethink this. So, in terms of what can be those technologies we have, drones and robots and so on, do in such a way that we can have redesigned systems that work much better.
So it's actually this rethinking process that the science comes in directly. Because without science, we cannot rethink the systems.
I'm not so sure, because this is this is also a big question, right? So who rethinks, right? So who are the real innovative thinkers? It's not always the scientist. It's rarely the scientist, in fact, because there's a big landscape out there of farmers, innovators, and so on, that are often much better at rethinking than we are as scientists. Because as scientists, we are often restricted into the boxes we have in terms of our disciplines and methodologies and so on. We are very good as scientists when we have a focus on going for that focus, documenting things, proving that technologies work, and also improving on things and so on. But we are rarely very good at completely rethinking.
How good we are in communicating and learning from the actual actors or farmers. I mean, in science, how good we are to keep this contact very close, because there's a lot of context-specific, or what we call in quotation, traditional knowledge that we can learn and employ in developing more sustainable solutions, and how good we are at that.
Yeah, well, I'm not so confident that much of the traditional thinking actually is necessarily so good. But there's a lot of knowledge, of course, out there, and there's a lot of farmers, innovators, and so on that know about their system, that all of the time think, okay, can I do this differently, right? So it's also a question of what do you mean by traditional knowledge and so on. But I would then, if you frame it in terms of the knowledge that actors, including farmers, have, there's certainly a lot of interesting ideas and so on out there that we should learn from, try to improve and so on. some of it honestly also doesn't work. And some of it is even sort of beyond what scientific thinking and merits and so on would say could at all work, right? So we need also in that dialogue, because I think there's a need for an honest dialogue between us as researchers and those farmers, innovators out there that are trying to improve things and get other things working. And we should go in with that with an open mind about it. Sometimes also we think, okay, this doesn't work and so on, but we should have that open mind in terms of saying, okay, maybe there is something to it. At least we could test it.
And I was thinking, can you also tell us how context-specific is the employment of technology and science in agroecology? I mean, we talked about Danish examples a bit now, but how could it differ from one country to another when we talk in agroecological terms? How could it be different? How the technologies are different?
I think there's a couple of issues related to this. Something is about the context specificity, because of course soils, climates, and so on are different. But also those issues we need to deal with, for instance, with environmental impact, may be very different. In Denmark, for instance, we have a big issue with nutrient loadings to our coastal ecosystems. That is not the case if you're in the middle of the US, for instance. Well, it would be if it's close to the Mississippi River, but otherwise it's not an issue. On the other hand, they may have a big issue on water and in having a lower impact from the water footprint, which is not an issue in Denmark because it rains all of the time. So it's that is not a problem. So there's a context specificity also about what are the issues, and that of course has impact on what technologies that we have in play. But there's also what you can call the readiness level of the actors in terms of taking on board new technologies, because that often requires that you can make the investments. It also, much of it also requires you have knowledge to implement this. So that readiness level in terms of applying new technologies varies considerably across the globe.
So it actually, it is the
industrial and
it is the challenges that defines which technologies we need in an area or in a country or in a specific context.
But you also need to think about what is the readiness level of the implementation of technology, right? So, for instance, what I've seen in Tanzania, for instance, right, is just having a simple equipment for sowing plants is a very important technology that is generally not available because it's still done by hand. And the problem with that is that takes much too long time then to seed the crops. So you don't meet the exact time, the optimal time for seeding plants, and then crops fail and so on. So if you could just speed up this 10 times maybe, because you've got a sowing machine to do things. And this would be, of course, be an equipment we wouldn't think of in Denmark as at all being an issue.
That's very true.
Can the audience ask a question?
Please.
Yes.
Is there a risk that this could also create or make disparities even bigger than now? So if the level of readiness is different and the access to technologies is different, could this make disparities that are already existing even larger then?
Yeah, but that is basically a question, I think, of that readiness level, but also really an issue of how do we improve farmer readiness level around this. And fortunately, actually, we do have technologies that can close that gap. in particular the IT technologies, smartphones, maybe just even ordinary mobile phones, is an extremely effective tool in order to get some of that knowledge and information out there, even just also to provide finance for this. So small-scale loans, for instance, that you can get through your phone and so on, the way you can sell and market your crops through phones may very much improve also upon the ability of small-scale farmers to actually adopt some of those new technologies that could improve their productivity also in agroecological systems.
I actually have another question, maybe not very relevant, but I always wondered, how could we better help with the education as people in science who actually research a lot and come to newer results? How can we communicate it better, and how can we reach out to a more broad audience to just educate at least the farmers about the new developments and how they can employ them for better practices, for better management? Are we doing a good job in that, for example, in Denmark? Or do you think that there's a long way to go in that?
We can always do better. I mean, traditionally in Denmark, we've had a close collaboration between the research, university sectorial research institute and so on, and the farming community. And the farming community have also organized themselves with centralized innovation offices and so on. So we have that collaborative community between university research and the farming community. We have the same thing actually integrated also with the major Danish agricultural companies, slaughterhouses, dairies, and so on, which are also integrated in this loop. And we, one of the benefits we also have is there's a joint funding mechanism also for collaborative research. So I would say in that way, things actually work pretty well. We also jointly organize conferences, webinars, and so on between this, reaching out to farmers, also stakeholders, and so on. So in general, this works well. However, I think we still have, because we are approaching now also considerable transformation, this green transition that we're looking into, where we do want to move to a situation within 1 or 2 decades of substantially reducing environmental climate pressures of the agricultural production system. That is a huge task. And if we were to do this through normal ways, right, it would likely take us too long. So we need to see how we can speed up, in particular, the implementation part of things. So something we're thinking about now is to have what we could call some demonstration innovation farms, where some of the technologies we're working on, also from the research side, in an early version comes on to real farm demonstration testing sites, where we can learn from this, but also where the rest of the farming community learns from seeing what goes on there. And then we can also look at, okay, is there something that doesn't work? Is there something we need to improve upon? We can look at barriers for implementation and so on, the cost of this. Having much of those data that would otherwise takes us several additional years to get, right? So it's a question of speeding up the process.
I think my final question would be that you very briefly mentioned something about the robots, and I know that AgroIntelli in Aarhus University does a lot of work on the robots for agriculture. For a lot of people, that could be a bit controversial to use robots in agroecological context. I don't think that, but I would like to hear your thoughts on that. How do you think they are contributing, or they will, because there's a lot of environmental impact assessment that needs to be done? How are they contributing to a better, more sustainable food production?
I think that if we take, I mean, now we talk about robots in crop production, because there are also robots in livestock production systems.
Yes, yeah.
But robots in crop production systems, I think, there's a couple of advantages for this. One is we can downscale the size of the equipment, because currently we have upscaled in terms, and this is simply for cost considerations, right? The cost considerations in commercial farming tells us that we need to have big equipment where one person can handle a much larger area. And this is simply because if we look at the industrialized countries, the major cost is labor, right? So what robots would allow us to do is to manage land with less labor cost, simply because the robots do not necessarily require that labor. They can work around the clock and so on. So we can downscale the equipment. We don't need the big equipment, right? Which will save in terms of soil quality, because then we don't have that large equipment compacting soils. And the soil compaction is one of the threats we have to soil quality. It clearly is a threat. It also has impacts on some of the emissions of greenhouse gases and so forth. So this is one issue, the downscaling of that equipment. The other thing is that by having small scale equipment with sensing systems on board, because those sensing systems on board can actually much more detailed manage the crop depending on what the crop situation, soil situation is in a specific part of that field, not across a 24 meter wide swath of a big machine, but much more closely. This would also allow us to manage cropping systems where it's not one monoculture over 10 or 20 hectares. We can work with strip cropping systems much more, where we have those interactions, and those interactions by having more plant species on a piece of land will deal with some of the crop pest, weed, disease issues that we otherwise need the pesticides for. So we can work on some of those agroecological aspects without investing a lot of labor, because otherwise we have that cost issue to it. So robots, I think, is a crucial part of this.
That was very educating for me as well. So I'm quite happy that we had this talk. Chiara, do you have anything else to add or ask?
Now, it's a very tricky question, but if you had to leave us with a take-home message of how can agroecology employ scientific innovation for a more sustainable food production system, what would you say?
Technologies, in my view, are essential for developing agroecological systems, simply because we need the technologies to optimize and manage the interactions we have between the plant species, the soil, and the soil organisms. We need to work on that, on optimizing this, both from a plant genetic perspective, and we need to work on this from an sort of machinery optimizing perspective in terms of having the right equipment to manage this. And this is where digital technologies and also genetically based technologies are particularly important.
Thank you so much for all the information.
Oh, you're welcome. No problems.